So we'll start solving the homework problems. Fine. The first one is okay. That question we'll solve that. Write the question here. So we have to prove that the beta function of m plus 1 comma n plus the beta function of m comma n plus 1 is equal to the beta function of m comma n. All right, so we'll start from the left hand side. So left hand side says that I'm supposed to write beta of m plus 1 comma n plus the beta function of m comma n plus 1. Now let me substitute. So let me substitute a beta of m comma n. What is beta of m comma n? In terms of gamma, I'll try to write. So that is gamma m gamma n by gamma of m plus n. This is what I'm supposed to write. Okay, so instead of m, I have m plus 1. So apply that rule. So this is gamma function of m plus 1 into the gamma function of the second function whole divided by sum of them. So this is a gamma function of the sum. So that is m plus n plus 1. First term plus was a substitution for the second one. This is also going to be same, right? So I'm writing the same way now. So this is gamma of the first variable, that is m, into the gamma of the second variable, that is n plus 1, divided by once again the gamma of the sum. Sum is nothing but this is m plus n plus 1. Okay, now what I do here is let me use another property. The property is gamma of I'll change the variable now. So let me, instead of using the regular m, I'll use say some other variable, say p. Okay, so gamma of p. I don't want to just use just p. I want to use p plus 1 maybe. So gamma of p plus 1 is equal to what? It's p times gamma p. Correct? This is the other property. So let me use it now. Wherever I have a plus 1 in my equation, I'm going to replace this. So this means the same thing. Left hand side is equal to, so m plus, there is a gamma m plus 1. I can write that as m into gamma of m, okay, plus gamma, my mistake, it's not plus, I have to multiply that now. So for that reason, let me simply write this as m gamma n into, I'll write gamma of n. Okay, the gamma of m plus 1, I'm writing that as gamma m gamma n. Now the next term is, by default, I have a gamma n over there, whole divided by, in the denominator also I can do the same thing, right? So gamma of anything plus 1, p plus 1, right? I'll consider the m plus n as p, so that means it should come out now. So that is m plus n times gamma m plus n, okay, plus do the same thing for the second half. This is gamma m as it is, but gamma m plus n plus 1, I can write it as n into gamma of n whole divided by, this is once again m plus n into gamma of m plus n. Okay, now I can see that in this whole equation I have the common term. I'll take the common term out. What is the common term? The common term is nothing but, see here, the gamma m is common in both terms. Gamma n is common. I'll take that out. Divided by, in the denominator I have m plus n into I have gamma function of m plus n. So this is gamma of m plus n. This is common. What remains inside is there is a m in the first term and n in the second term. Now I can see that I can cancel this, right? When I cancel this, what I'm left here is, right? What I'm left here is gamma n into gamma n whole divided by the gamma of m plus n. This is nothing but a beta function, beta of m comma n. So that's what was the question. Okay, that was the first question. Then now let's go to the second question. So straightforward, we just have to apply some of the basic rules, that's all. Okay, all right. Now let's go to this next question. This is the beta of m plus 2 comma n minus 2 divided by, this is m into m plus 1. This should be equal to the beta of m comma n whole divided by n minus 1 into n minus 2. This is what we want to prove. All right. So our approach remains same here. We'll start from the left hand side. Okay, so left hand side is beta of m plus 2 comma n minus 2 whole divided by the m into m plus 1. So applying the beta function to this, okay, this is equal to beta of m comma n is, first I have to write the gamma function. So this is gamma of m plus 2 into the second function, it's second variable, that is n minus 2 whole divided by the gamma of this sum. So gamma of m plus 2 plus n minus 2, plus 2 minus 2 cancels out, you are left with m plus n. Okay, into, there is a denominator term already present that I'll write after this. So that is m into m plus 1. Okay, now let us try to make a substitution. So the substitution that I'm going to write here is we use this. So we know that, so I'll write this is 1. So we know something. We know that if I have gamma of n, I can write this as n minus 1 into gamma of n minus 1, 1 less than that always. Okay, so this implies I'm going to apply the same thing to the gamma of m plus 2. So because I have a gamma m plus 2 in my equation, so this means I can write this as 1 less than this term, that is m plus 1. Because m plus 2 is there, I have to write it as one term less than that into gamma of that less than term, that is m plus 1. I can write this. Okay, so I'm going to apply that now. So this is the term. So let's apply that. So this is equal to, this implies, now equation 1 becomes equal to, so there is a gamma m plus 2. So gamma m plus 2 is nothing but m plus 1 gamma of n plus 1 into gamma of n minus 2 whole divided by, I have gamma m plus n into m plus 1. Okay, also what we do here, in order to make further simplification, I'm going to multiply and divide by this term, that is into n minus 1 and n minus 2. So what I do, I multiply and divide by the n minus 1 into n minus 2. This is, I multiply and I divide. Okay, n minus 1, n minus 2. Okay, now what happens? See, there is n minus 2 gamma n minus 2, right? I can see that. Can you see this, that term here? So there is a n minus 2 gamma n minus 2. What is that? N minus 2 gamma n minus 2 is nothing but it's gamma n minus 1. Okay. gamma n minus 1 into gamma n minus into n minus 1 is nothing but gamma n. Okay, two terms are getting multiplied, so I can write that. Right now I'm going to use this, so I'll write that what I'm using now here. So that is, if I have n minus 2 into n minus 1 into gamma of n minus 2 is nothing but gamma n. I'm going to use this. Okay, let's apply that. So once that comes up, now what happens? So this is equal to, I have a m plus 1. This m plus 1, m plus 1 will cancel out. Okay. Now, so as a result, overall, what I can write now, right? What I can write now is this. I'm left with gamma m and gamma n. In the numerator, I can say that I can see that there is a m plus 1, m plus 2 can be written as m plus 1 into this. This I'm going to write m plus 1. I'll further simplify. Gamma m plus 1, I'm going to write this as m gamma m. Okay, that I'm writing this m plus 1, gamma m plus 1, I'm writing it as m gamma m. Okay, next, into I have the other function. What's the other function? That is gamma n. I know that I'm writing that as gamma n, right? That I'm getting from the previously used equation. Whole divided by, no n minus 1, n minus 2. Okay, that's what has been taken care of. In the denominator, I have gamma of m plus n into, you can see that there is a m, into 1 divided by n minus 1 into n minus 2. So just see that this m and m also will cancel. So once that cancels out, what I'm left over in the first half is nothing but this is beta of m comma n. Gamma m into gamma n divided by gamma of m plus n, which is beta function, whole divided by the remaining term. Remaining terms are n minus 1 into n minus 2. So let's go back and check the question once. So what we are supposed to prove, you can see that this is the term which we are supposed to prove. Beta of m comma n divided by n minus 1 into n minus 2. Just now you can see that we got the same answer. That's here. Okay, so we prove this. This is equal to the right hand side of the given question. Okay, then let's go ahead. The next question to be solved is this one. Okay, beta of m comma n into the beta of m plus n comma p should be equal to beta of n comma p into beta of n plus p comma n. Okay, so approach still remains same. We'll start from the left hand side of the equation. Okay, so that is nothing but the beta function of m comma n into the beta function m plus n comma p. We start from this. This is equal to substitute for beta m comma n in terms of the gamma function. So that is, this is gamma m into gamma n whole divided by the gamma of m plus n by using the basic definition, into, do the same thing for the second one, that is the gamma of m plus n into gamma of p whole divided by the gamma of m plus n plus p. Okay, so this is equal to, let's try to cancel the terms. What we can cancel, I think we can cancel out gamma function gets cancelled. right? Okay, after cancelling, what remains I'll write. This is gamma m, gamma n into gamma p whole divided by gamma of m plus n plus p. So we don't have any equation to resolve this into the smaller quantities and simplify. So we'll hold on to this and we'll solve the RHS now. Okay, so let's try when we solve the RHS, will we get the same answer as 1? Okay, so that we can prove it. So let's start with the RHS. Right hand side. What is the right hand side? It says that it is beta function of n comma p into the beta function of n plus p comma n. So this means apply the same fundamental equation once again. So gamma of the first function, that is gamma of n, gamma of p whole divided by gamma of n plus p multiplied by this gamma of n plus p into gamma of n whole divided by the gamma of m plus n plus p. In this I can cancel this, so what remains is gamma m, gamma n into gamma p whole divided by gamma of m plus n plus p. So call this is equation 2, right? We can see that the equation 1 and equation 2 are same, is equal to equation 2, hence that is a proof. Okay, all right. Now these are the extension of the properties which we had studied earlier. All right, now let's go further. Let's try to write maybe okay, let's try to solve some very simple problems. Some of the values given and we want to solve those values. Okay, so for example, let's try to evaluate the value. So find the value of the following will be the question. The first question is solve gamma 3, right, into gamma, that should be okay. Okay, so let's like this. This is gamma of say 2.5 whole divided by gamma of 5.5. Okay, right? So pretty straightforward. If you remember, if it's a if inside the bracket, if you have a whole number integer, this is going to be represented as a factorial. Okay, if it is not factorial, sorry, if it is not a real number, if it is not a integer, sorry, not real, if it is, I repeat, if the gamma function what we are trying to find out does not have an integer, then I have to apply n gamma n, that equation. Okay, so gamma 3 means it is an integer, it's 1 less than that number, it's factorial, so that is 2 factorial. Okay, that's the value of gamma 3, right? So just recall, I'll write here alright, okay, gamma of n plus 1 is n factorial, right? This is for integer. Okay, otherwise the gamma of n plus 1 is nothing but n into gamma of n, so this is others. I just have to use this now. So I can see 3 is a integer, so 1 less than that number will be written as a factorial, so that's 2 factorial. Now gamma 2.5, what is gamma 2.5? So 2.5 is actually n plus 1. I have to write 1 less than that, so n gamma n, that is actually 1.5 into gamma of 1.5. Okay, But gamma of 1.5, I can write it as 1 less than that, right? So that is 0.5 into gamma 0.5. Okay, so gamma 2.5 is nothing but 1.5 gamma 1.5, but that gamma 1.5 can be further reduced to zero point 0.5 into gamma zero point 0.5. This approach needs to be written, needs to be applied for every problem. Okay, now this, I have this, I'll divide this by gamma 5.5. What should happen? Start from 1 less than that and keep reducing the terms until you get 0.5. So that means I have 5.5, start from 4.5. 4.5 gamma 4.5. Sorry, my mistake. 5.5 gamma is nothing but 4.5 into gamma 4.5. But gamma 4.5 is nothing but 3.5 gamma 3.5. So 3.5, the gamma is written as 2.5 gamma 2.5. But gamma 2.5 is 1.5 gamma 1.5. What is that 1.5 gamma 1.5? 0.5 gamma 0.5. Either you find the value of gamma half, I know the value, otherwise you simply cancel them, both of them. Now you see that it's very simple. 2 factorial, 2 factorial is 2, 2 into 1.5 into 0.5 whole divided by 4.5 into 3.5 into 2.5 into 1.5, 0.5. Okay, so let's solve this in calculator. Out of which you can see that these things will get cancelled, 1.5 and this. Okay, I just have to do 2 divided by 4.5, 3.5 by 2.5, so that comes to be, I'm getting 16 divided by 315 as the answer. Alright, so that's the answer. Please verify yourself to confirm. Now we'll go for the next question, that is, say, all right, 6 times gamma 8 by 3 divided by 5 times gamma 2 by 3. We'll apply the same rule now. So 6 into, now I have 8 by 3. So 8 by 3 is nothing but 8 by 3 is bigger than 1. Always remember, whatever you write inside the bracket should be greater than 1. I can reduce the gamma functions only up to I get a positive number. As soon as it becomes a negative, I should stop. So which means I have 8 by 3. So 8 by 3 can be written as 8 by 3 minus 1. 8 by 3, if you subtract 1 from that, I get 8 by 3 minus 5 by 3. Okay, so this becomes 5 by 3 gamma 5 by 3. But from 5 by 3 also I can subtract 1. So that means it is 2 by 3. So this is 2 by 3 gamma 2 by 3. You see that I cannot go further. If you subtract 2 by 3, 1 from 2 by 3, it becomes negative. So that's not possible. We'll hold on to this. This is 5 into gamma 2 by 3. Why the gamma 2 by 3 is given in the denominator is because you can cancel it out. Okay, now becomes very simple. I can simply write the terms over here. So 5 cancels, 12 by 9, so 4 by 3 is the answer. Pretty straightforward. All right, then, okay, let's go to a different question now. Okay, the next question is this one. Okay, so find this value. This is the next question. That is beta of 7 by 2 comma minus 1 by 2. Okay, this is a question. We have to find this. I apply the gamma rule. So this is gamma 7 by 2 gamma minus 1 by 2 whole divided by gamma of m plus n, right? That is m plus n is 7 by 2 minus 1 by 2, 6 by 2. 6 by 2 is 3. Okay, so this is definitely I can write gamma 7 by 2 as 1 less than 7 by 2, which is 5 by 2 into, can I reduce 1 from that? Yes, this becomes 3 by 2. Can I further reduce that? Yes, this is 1 by 2 gamma 1 by 2. After 1 by 2, if I further reduce, it becomes right. I cannot further reduce that. So gamma of minus 1 by 2, I can write this as, you can see, we'll use this property. If you have gamma n is equal to n minus 1 gamma n minus 1. Okay, take this n minus 1 as minus half. So if I write gamma of minus half here, this will be minus half. This is equal to 1 plus 1. That means gamma half. Are you okay? I can write gamma half as minus half into gamma of this number. This is what is the rule that I'm going to apply now. Okay, this is what I'm going to apply. So into, there is, because I have a gamma of minus half over there, that I can write it as, right? Take this, only this term I want. So minus half will go to the denominator. So that is gamma half divided by minus 1 by 2. This is the numerator, whole divided by gamma 3. Gamma 3 is nothing but, we know that it is 2 factorial, right? So we'll simply write that as the 2 factorial. All right. Okay. So when we simplify this, this is how we are going to simplify. This is 2 factorial. So I'll go down to simplify this further. So this is equal to, I think when I multiply this, okay, so 5 into 3, 15 by 8, okay, into, there is a gamma half. If you remember, gamma half is root pi, into the minus 2 will go to the numerator because there is a minus half in the denominator, into one more root pi, whole divided by the 2, because 2 factorial is 2. This and this will cancel. So no need to simplify. You can write the answer here itself. That is 15 root pi into root pi is pi by 8. You can simplify. You can use a calculator. 15 into 3.14 by 8. Whatever is that answer, you can write. Okay. Okay. Now we use this the following property, right? The property is like this. I'll write it once again. That is, so we know something. We know that if you have gamma n, I can write it as n minus 1 into gamma of n minus 1. Right. So what I do here, I'll do the reverse. Let me assume that this gamma minus 7 by 2 is a negative number. It comes only from some positive numbers being subtracted by 1. What I do, I'll write this. This implies I can write, if you want to find gamma of n minus 1, which is a negative number, this is going to be gamma of n whole divided by n minus 1. Otherwise, I can actually rewrite this as, this implies the gamma n can also be written like gamma of n plus 1 divided by n. correct? Replace n minus 1 by n. Every n becomes n plus 1. So this becomes n plus 1. N minus 1 plus 1 is n. I can write this. Alright. So this approach we have to use now. So this implies, now you write this. This is gamma of minus of 7 by 2. This is equal to what? Gamma n plus 1. Add 1 to that. What is that? Gamma of minus 5 by 2 divided by that number. The n is nothing but, I can see that this n itself will come here. That n is nothing but minus 7 by 2. So minus 7 by 2. This is equal to, now you can see that I have a minus 5 by 2. I can further simplify this in the same fashion. So I can rewrite minus gamma of minus 5 by 2 using, add 1 to that, that is minus 3 by 2 divided by, there is already a minus 7 by 2 into this number, right? That is minus 5 by 2. 5 by 2, right? When you had minus 5 by minus 7 by 2 plus 1. So that is minus 7 plus 2 by 2. So this is equal to minus 5 by 2. Okay? Take a common denominator and solve. Now, numerator has a minus 3 by 2 in that. Once again, I apply the same thing. So when you add 1 to that, this becomes gamma of minus half divided by, all numbers remain same, minus 7 by 2 into minus 5 by 2 into minus 3 by 2. So this is still a negative number. Whenever it is negative, I don't have any option. I have to express the same technique. I have to use it the same technique. So minus half, I add 1 to that. So what happens? This is gamma of plus half. Now I have an answer to that. But I still have to use the denominator now. Minus 7 by 2 into minus 5 by 2 into minus 3 by 2 into minus half. Okay, all the negative sign will go away because I have 4 minus signs. It will cancel out. So this is 2 into 2 into 2 into 2. So that is 2 to the power 4. In the denominator, it will go to the numerator into gamma half. Gamma half is root pi whole divided by 7 into, how much? 7 into 5 into 3. 35 into 3, 105. Okay, so this is 16 root pi by 105 is the answer. Okay, the next question is this. So solve. This is the simplest function, that is solve integral 0 to 1 log of 1 by y to the power n minus 1 dy. Okay, so this is the question. Now you can see that this is impossible to solve using the basic definitions of integration. Basic rules of integration cannot be applied here. This is not simple log function. Log of 1 by y is there and whole has been raised to a power n minus 1, some n. Okay, so right, we need to bring it into some standard format, then only we can apply. So what you do here, in this function, this is equal to, what I do, I try to apply a function. Let me take the log of 1 by y, right? Put log of 1 by y, say I'm going to put this is equal to t. Okay, so just to cancel the log, I will take e to the power on both sides, right? That means this is 1 by y is equal to e to the power t. When you raise both side by e to the power, log will cancel on one side, other side I have this. So this implies I'll invert the function. right? Y will go to this side, e to the power t will come to the other side. This implies y is equal to e to the power minus t. Are you okay? Right? This means I differentiate. This implies wherever I have dy, I can write it as minus of e to the power minus t into dt. These are the substitution I am supposed to make in the above equation. Also, when I make a substitution, I should take care of the limits. You can see that in this question, limits are 0 to 1. So I should look what happens when y is equal to 0, what happens to t, right? So y equal to 0 means, what is t? T is equal to log of 1 by y. Log of 1 by y. 1 by y is 0 means 1 by 0 is infinity. Log of infinity is, right, I cannot define, so t is also equal to infinity. Okay, so that's my case. This means t becomes equal to infinity. At the same time, the other limit is y equal to 1. Y equal to 1 means t is equal to log of 1. Log of 1 is 0. So I have the limit t becoming equal to 0. Okay, apply this now. So this is equal to the same function. Now it is t now. T is equal to lower limit becomes infinity and upper limit becomes equal to, sorry, just 1 second. I think my, yeah, can you see now? This is what the limits are for t. T is equal to infinity till 0. Okay, infinity to 0. That means it is infinity to 0. I have to update my function. So the function, if you see, it's log of 1 by y is t. So this is t to the power n minus 1. T to the power n minus 1 into, see, that is minus of e to the power minus t minus of e to the power minus t into dt. Simply we made a substitution. Okay, now what I do, I want the limits to be 0 to infinity, so I take a minus outside. Okay, minus t is equal to 0 to infinity. I'll write minus e to the minus t into t to the n minus 1 dt. So this minus will cancel out. For simplicity, I'll write whatever is there once again. So this is integral 0 to infinity e to the minus t to the n minus 1 dt. But if you look at the definition of a gamma function, this is nothing but simply gamma of n, right? So that whole integral, which looked very complicated, right, is nothing but a simple gamma function. Simply we know how to find a gamma n. If it is n, if the n is an integer, right, simply I can write that integer, I can use it using a factorial. I can solve using a factorial. At the same time, if this gamma function, in if that n is a fraction, I can further use it as n minus 1 gamma n minus 1. I can apply and I can solve it. So that's what is the indication that any complicated problem like this can be solved using gamma functions or beta functions. All right, let's go further. Okay, okay, next question. I will give the next question now. This is a question. Okay, uh, find the value of integral 0 to infinity root of y into e to the minus of y square dy and into one more, integral 0 to infinity e to the minus y square divided by root y dy. All right. So what I do here, I have two integrals to be multiplied. So I'll split them. I'll take one by one. I'll solve them. Then I multiply. So let I1 is equal to the first function. Okay. The first function is nothing but, if you see this, this is integral 0 to infinity, right? Root y e to the minus y square dy. That I can rewrite as integral 0 to infinity, right? E to the minus y square into y to the power half into dy. Okay, then let me write I2. I2 is equal to the second function, which is 0 to infinity e to the minus y square divided by root y. Okay, this I can into dy. This I can rewrite as, yeah, I'll try to rewrite this as integral 0 to infinity root y. I'll take the numerator, take it to the numerator as y to the power. Okay, I can write that later. First, let me write the e to the power. Really, that makes it easier. Okay, so this is e to the power minus y square into y to the minus half dy. Okay, but we know something. What is that? How do you write a gamma function? Gamma n is equal to 2 times 0 to infinity, right? E to the minus x square into x to the power 2n minus 1 dx. So I have to compare this equation to both I1 and I2. So there is no 2 here, which means it is half of that gamma n. I need to find what is that n now. Are you okay? So because in each of the case, I have to compare this with this and this so that you can find what gamma functions are they, because they are simply gamma functions. Find out what gamma functions are there, simply substitute the value of n, you have an answer. Okay, right. So what I do, very simple. See, this is the procedure. I will equate like this. So that y to the power 1 by 2 is there, right? That should be equated to 2n minus 1. So in I1, I'm going to equate 2n minus 1 should be equal to plus half. This implies 2n is equal to 1 by 2 plus 1, that is 2 plus 1, this is 3 by 2, right? This means what? This means this is equal to 2n, n is equal to 3 by 4. I understood that. My first function, this implies the I1 is equal to n is equal to 3 by 4, right? But there is no 2, so I should divide by that. So that is gamma of 3 by 4 divided by 2. Or you can simply write half uh, gamma 3 by 4. Half gamma 3 by 4. This is I1. Similarly, in I2, in the second one, what I'm supposed to do, I have to do the same comparison. The 2n minus 1 should be equal to how much? You see the power. Power is minus half. Okay. This implies, do the same calculation. 2n is equal to minus half plus 1, that is plus half. This means n is equal to 1 by 4. Therefore, the I2 now, the second integral is nothing but the gamma of n is equal to 1 by 4. Since there is no 2 in the equation, I have to divide that by 2 to compensate that. So this is half gamma 1 by 4. Okay, so I got 1 by 4 as n value and substitute that. Okay, so this is 1 by 4. Now I1 and I2 should be multiplied. So final answer, therefore the I1 into I2 is equal to 1 by 2 gamma 3 by 4 into 1 by 2 gamma 1 by 4. So you have the answer. 1 by 2 into 1 by 2 is 1 by 4. What is gamma 3 by 4 into gamma 1 by 4? We had proved this. This is pi root 2. That's why I told those values are important. Okay. So this can be reduced as, simply you can keep this pi root 2 by 4, or root 2 cancels with 4 as 2 root 2. So you can get pi by 2 root 2, or you can simplify and write the answer. That's also fine.